Army mateys, welcome to this episode of Unity Bits, the first ever episode, and in this episode, I'm gonna show you how to make a camera-bound component. So, if you want to have a camera that you can pan around, but that it, basically you can set a rectangular bounds out of which it cannot go. How do you do that? Well, let's talk about that. What I have here, I went ahead and set up an initial scene. I've got a main camera and it's orthographic, at which this method will only work for orthographic cameras, so make sure that your camera is orthographic. I have a couple of sprites set up just so that we can move around the scene and we can basically see that the camera is moving. That is if I select the right thing, see? And then I have this bounds object, which let me go ahead and we'll delete that. Let's recreate it. Bounds. So there's a bounds object, and this is what we're going to use to hold our new component that we're going to make. So this camera bounds component. So let's go ahead and add a script, and let's call it. Actually, let's do it like camera bounds. Let's call it that. C#, and then let's click on it. And as you can see, I am using Visual Studio for my editor. Okay, let's just get rid of all this stuff. Okay, now what a lot of people will do, and I've seen several people do this, and that is they'll say, hey, you know what we need to do? We need to be able to specify that bounds, and they're right. You need to be able to specify that bounds. So a lot of people naturally think of, hey, let's use a rectangle. Okay, well, I don't like the way you edit this. This is crummy, because I would rather edit it here because I can see what I'm doing. I don't want to have to go here and X and Y and width and height and go twiddle all these values. So we're not going to do that. We're going to do it a more sophisticated way, if you will. So let's remove this and let me draw your attention to this transform here. Well, we know now that Unity now has two types of transforms. This standard transform has been from Unity with Unity for the whole entirety of its life, and then the newer Rect Transform, which came along with the Unity UI system. And it is that transform that we are going to utilize because it has built-in support for editing those handles, and that's exactly what we want. We want to be able to edit and drag the edges and such, so that we can just specify that in the editor itself, as well as we can go over here and do what we want. Let me show you what I mean. So what we're going to do is we are going to, with our component here, we're going to require that we have a Rect Transform, because we needs one. And we also are going to want to store a reference to that, and let's grab that in the awake function. So we say Rect Transform equals transform as Rect. Did you know you could do that? You can do that. You can totally do that. All right. So what we'll probably need to do, since this is just a transform, let's see. I don't even know. Does it actually? Yeah, it doesn't. So in order for that require to work correctly, we have to remove it and then re-add it. And then when we re-add it, it makes sure to add a Rect Transform to our game object. So here we are. So we have a Rect Transform, and let me show you. See, already, if you go to the this particular tool, which I believe is T, then we can see that we can utilize that, and actually it's very small right now. That's why we can't see. It's very large. I mean, see how we can change these so much better, and we can actually hold down Shift, and we can get a resize while respecting the perspective or the aspect ratio, which is nice. Then we can hold down Control, and you get this squishing effect, which is pretty nice. So there's different ways that we can edit it, and we can also drag it around. So this is really great. This is what I want right? This is what I want whenever I'm resizing a rectangle and trying to make it, put it, you know, this is going to be where our bounds is going to be limited to. So this will be our camera bounds. So what we're going to do is we're going to go into late update, because we want to do this after everything else has been done. And we want to use this Rect Transform. We want to use, specifically, we want to use, of course, the X and the Y position. We want to use this width and this height also. But the problem with the Rect Transform is it's actually, if we go to Rect, you see the calculated rectangle in the local space of the transform. I don't think that's going to work. So how do we do this? Well, there is another, we want the world space, right? We want those corners, those world space corners. Well, there happens to be a great function called get world corners on the Rect Transform. And all it asks for is a vector 3 array with a size of 4. Well, we're going to be doing that quite a bit, so let's have a vector 3 array up here, and we'll call it, let's just call it world. Let's call it world corners. I mean, why not, huh? And then in the awake function, we'll say that's a new vector 3, and it's going to be 4. We need 4 of those. So then all we have to do is say get those world corners. So now it's going to translate, or use its translation matrix and translate this from this local coordinate system to a world coordinate system, which is exactly what we want, because we want to bound our camera to these lines, or to this rectangle, in world coordinates. So great, that's fantastic, right? Okay, so we've got the world coordinates, but now we actually need to create another, we need to make a rectangle of it. Just makes it easier. So let's call this, what do we call it? World bounds, maybe? And let's say this is a rectangle, and the rectangle wants a position. Well, see, look, it says the position of the minimum corner of the rectangle. Well, world corners, or the get world corners, happens to the first element happens to be at the bottom left. And I can drag this over and show you. You see this, it says, gets the corners of the calculated rectangle in world space. Each corner provides its world space value. In the returned array, it starts bottom left, which is what we want. We want that bottom left hand coordinate, because you see right here it says that position is the position of the minimum corner of the rectangle. That's going to be that lower left corner. So this is easy right here. It's just going to be world corner 0. Now, vector 2.size. So we need a new vector 2. Let me just do this, and let's bring this off on its own line, and let's do this additionally. So this is going to be the Rect Transform .rect, and the size is going to pretty much be the same. But we also want to take into account this scale here too, because that would be nice to be able to just scale it, because as you see, when it scales, we actually get that visual feedback. So we want to actually take that into account. So we want to say transform.local scale.x, and then for the y we will say rt.size.y, and not size delta. I don't know why it keeps doing that to me. Times, oh, that's why I forgot the rect. Transform.local scale.y. And then we're good. So now we have this world bounds that we can check against. I'm going to just go ahead and put that in to it. Struggle with that. Okay. Don't. It's good. It's all good. It's fine. This will work just fine for us, okay? So that's our world. That's our world bounds. So we grab those corners, and let me say this also additionally, if you don't want to have this bounding rectangle for your camera change during the running of the game, the execution of the game, you can of course put these calculations into the startup method, and then with the update you don't have to calculate it every time, but this will be fine. It's not a big deal. So we're going to leave this. Okay, so now we want to get the camera extents. So we want to get the Y extents from the center of the camera. How tall is it? And we want to get basically a radius, and a Y radius and an X radius, because we're going to use those to determine if our camera is inside these bounds or not. So in order to do that, we need our camera. So where our camera is, we don't have a camera yet. That's right. We need to say we want a camera, and we'll call this bounded camera. How about that? Bounded camera. So we have to put that in whenever we start our little process here. Yep. Yep. Okay. So we're going to need some what I'm going to call view extents, right? So that's not the entire size. It's basically that X and Y radius of the view rectangle. So we're going to say view extents equals a new vector 2. Okay, watch this now. Here's how we're going to get this. Now remember that I'm going to put 0 here. Let's do the Y real quick first. The Y size, the Y extent is going to be that bounded camera dot orthographic size. Look at what it says. Camera's half size when in orthographic mode, and that is the Y size. That's exactly what we want for Y here. Beautiful, lovely. Now, the other X is a little bit more obscure, right? Bounded camera. What we're going to use is the aspect ratio. And look at that, it says it's the width divided by the height. So we want the width of this thing, the extents. So we're going to take that aspect ratio, and then we're just going to multiply it by the Y size, because this is the width divided by the height, and you multiply by height, and then you have the width. Hopefully that makes sense. Okay. So now what we're going to do is we're going to say bounded camera dot let's make another variable just to make things a little bit easier. So let's call it camera position, cam pause, and we'll say because otherwise it's a lot. This is just a lot to type otherwise. So we're just going to set it to bounded camera dot transform dot position, right? And lastly, what we want to do is we want to set bounded camera dot transform dot position to a new vector 3. How about that? A new vector 3. Okay, so let me just go ahead and we'll do some placeholders. We'll just do them one on each line. So the Z component's going to be easy because that's just going to be the same camera position dot Z. We're not going to mess with camera position dot Z, the Z value, since we're in 2D mode here. Okay, so now what we're going to do is we want to limit the X position to be in between this left side and this right side of our basically our little Rect Transform we have here. So fantastic, we can do that. There's a function called mathf.clamp which will do that. It clamps a value between a minimum and a maximum, which is precisely what we want. So the first value, the standard or the value we want to clamp is camPosition.x for this. Okay. Now, think about this. We have these world bounds, right? Well, the world bounds, what we want is we want the minimum here. So, right, it says it clamps between the minimum and the max. So we want these, we want to take the world bounds, we want to take the minimum X component. So that's going to be that left side right here. It's going to be that left side. And we want to know when our position is more than or less than that world bounds dot minimum x plus half of our view extent, right? Because otherwise, if cam position is less than world bounds, then the camera position, the center of the camera is of course at those coordinates, and if we did that, then the camera could go all the way, the center of the camera could go all the way to the line, and then it would stop. But we want these extents to be included in that. That's why we got them. So all we do is we need to say the world bounds plus the view extents dot x, and that's going to get our minimum. That makes sense? Hopefully that makes sense. So our world bound minimum, so it can't be less than this number. So that's our minimum. And our maximum is going to be world bounds dot max dot x. So it's going to be that right side here. And we're going to subtract the view extents dot x from it. Okay? And now we're done with that. We're done with the x. We've done it. Okay, so this is going to be, it's going to be the same for y as well. And again, remember the extents are done because the center of our camera is where the camera position, the actual transform is. It's at the center, the very center. So we need those. We need to subtract and we need to add those extents depending on where we're wanting, how we're wanting to capture our camera. I'm going to take this and I'm going to I'm going to copy that, and I'm going to just change all these to y because it's all the same, right? So we're just going to do, right? So we're doing the same thing for y as we are for x. And let's see, I think, yeah, I've got some not important, but let's go ahead and fix those because I don't like warnings. Okay, so let's wait. We've got to put our camera as our bounded camera. So here's our bounding area. Let's run it. Okay, no errors. So let's grab our main camera and let's go to the transform tool here. Let's try to move it. Now look at this. Now, you can't see the bounds yet, but you see it is actually working. And then when I resize, let me go back to the handle tool. When I resize it, I go back to the camera, then I can't go above that. Let's do it one better. We would like to be able to see that bounds whenever we're in the Unity editor. So let's use let's do a processor processor define here. Let's do if Unity editor. So this is going to be a conditional compilation step, basically is what I'm trying to say. Let's do some conditional compilation. So if we're in the Unity editor, then let's have a function. Let's respond to this function called onDrawGizmos, okay? And we need to be careful with this because this runs in the editor. So while we're in the editor, world corners is not going to have anything in it. So we definitely need to check if world corners is null, then we just want to return. So we're going to draw our bounds so that we can see it in the editor. So to do that, we'll do Unity editor. We need to set a color. So we'll do that first. We say color, let's do color dot, I don't know, red, whatever. And then there is so now we'll draw our rectangle. And for this we'll use draw polyline. Now what we could do is I can come in here and put the world corners array in here, and that'll work. Oh, I have an else. I'm sorry. That's an end if. That's what was going on. Sorry. Okay, so what's going to happen is it'll draw that, as you can see here in a moment. Where are we going here? when we run it, you'll see it'll draw it. But I don't like that color. Let's make it yellow. Let's make it yellow. Easier to see. But you can see that it is half of it's cut off. Well, that's because this is a draw polygon line. So you give it each point. Well, we gave it 4 points, but it's point to point to point to point. So what we need to do, we need to give it that last point again. Well, it's actually a params. So it's multiple parameters that we can enter. So what I found is easiest to do is just to do the following. Right? And then we'll just do these manually like this. So from 0 to 1, from 1 to 2, from 2 to 3, and then from 3 back to 0. And now you'll see it whenever we press play. You'll see our rectangle. And now we can grab this camera, and then you'll see that it's all beautiful. Oh, and that's another thing. We're not seeing our little sprites move around. That's because they're both all at 0. So there. Now we can drag it around, and so then we can go back to the bounds, and I can go to the handle tool, and then we can move these in, and notice that the camera is moving when we do that also. Pretty cool, huh? So we can basically bound our area like we want it, which is wonderful. Set all this stuff up, and if we want to keep these changes while we're running like this, we can just copy the component. And then when we go back out, we can say paste component values, and it will resize. And then we rerun it. Let's grab the main camera again, and then as you can see, aha, we are captured. Our camera is not allowed outside of those bounds. Something else you might want to do would be public. You could say draw camera bounds, so that you don't have to see them all the time if you don't want to. And then I would just say if the world corners are null or not draw camera bounds, then just return. So what that would look like would be the following. It's not going to draw them initially, but then we can say, hey, draw camera bounds. See? As a matter of fact, let's rename that to say draw bounds. So there's a number of things you could do to change this stuff around. One thing, which I'll leave as an exercise to you, that is, we've got these camera bounds, but if we go outside those camera bounds, then we get this jitter. So something needs to happen. Either you don't allow the camera to go out to get that size, or you come in here in your late update and you check. You could check like right here, and you could see if you could say to do, see if camera extents, or let's say camera viewport is larger than the camera, than our camera bounds rectangle. If so, then we could either resize the bounding rect, or resize the camera to fit, right? So we could do that. Something else we could do is if we wanted to allow the camera to be dragged around, basically if we wanted this line to be the bounds for the center of the camera, we could do that too. That would end up looking something like this, and it would be we would just remove the view extents. Like I said before, that's really what makes it work as far as keeping the entire camera viewport inside. So if we did this, we run, we grab this camera, and we try to move it around. See, I can move it all the way to the center, and now, see, I can't go outside of that. So you could make that an option if you wanted to where you could say, constrain to the center instead of the entire viewport if you wanted to do that. So there you go, ladies and gentlemen, boys and girls. That is a camera bounds component that you can use to constrain any orthographic camera to your heart's content. And what is this camera bounds on draw gizmos? Array index is out of range. Okay, well, let's do this then. Oops. Let's say or world corners dot length is less than 4. Now does that go away? How's that? I guess it was sort of some sort of remnant or something. I don't know what's going on there. It should be just null. Yeah, that works. All right. So with that, I'll leave you to it. If you want to make any interesting modifications, you know, post it down in the comments. I'd be interesting to see what other kind of interesting, spiffy new things you could come up with to make this even better. Thanks for watching, and see you next time.